The business asked for a breakdown of total monthly sales, and you quickly built this aggregated table in Tableau. But that's just the starting point. The real analysis begins now. Now that this base view is ready, stakeholders can ask a variety of follow-up questions for deeper analysis. For example, they might want the running total of monthly sales for each year, or the MOM, which is month-over-month percent change in total sales prior to previous month, or a year-over-year comparison showing how a particular month's sales performed against the same month in the previous year. They may also want to see how each month ranks within a year based on sales volume, so that later we can create an insightful report where stakeholders can filter to view only the top performing or the bottom performing months in each year using a filter slider. All these type of calculations like running sum, percent difference, rank, percent of total and moving averages are known as table calculations in Tableau. In this video, we'll dive deeper into each one of them, starting with what a table calculation is, exploring quick shortcut implementations, and then moving on to manual computation using Tableau formulas. So stay tuned. But before we begin, let me quickly walk you through the agenda so that you have a clear idea of what we'll be covering in the next 1 hour of the discussion. We'll start with a quick refresher on what a table is and why these type of computations are called table calculations. Briefly revisiting some of the quick table calculations we have already covered in the earlier videos, like percent of total and cumulative sum. Next, we will deep dive into the core topics, starting with the business questions around cumulative sales. Unpack how Tableau's table calculation work, basically direction of computation, addressing and partitioning, build a month-on-month running total for each year, and then turn the raw numbers into an immersive area chart. After that, we'll explore different types of percentage calculations possible in a table, understand what each one reveals, and interpret their business significance. Then we will move on to another key table calculation called percentage change. We'll discuss how it helps in two crucial business analysis metrics, specifically month-over-month percentage change and year-over-year percentage change, and walk you through how to perform these computations in Tableau from scratch. Next, we'll look at another table calculation called rank. This one's super handy because it lets us rank the entries in a table and then give end user flexibility to filter out just the top performers or the bottom ones based on those ranks. And finally, we'll wrap up with one of the most important table calculation called moving averages. I'll walk you through what a moving average really means with a simple illustration, explain how it's computed and why it's such a powerful concept in analytics. We'll take an example from daily share price movement to make it more relatable, and then bring it back to our sales dataset to compute moving average right inside Tableau. So these are the table calculations we'll be covering in this video. And we are not just stopping at the concepts. We'll go through the complete Tableau implementation, break down the complex formulas behind them, and really understand how they work. Of course, there are many more table calculations out there, but we'll start with these core ones to build a solid analytical foundation and the problem-solving mindset. So let's get started. Before we jump straight into technical details of table calculations, let's take a moment to go over the basics. We'll quickly talk about what a table is, what we mean by table calculation, and do a short recap of a few table calculations we have already covered earlier. By this point, we are already quite familiar with the Superstore sales dataset we have been using throughout the course. It's basically a table of rows and columns, and any sample or subset of that full dataset is also a data table like this one. Now in Tableau, we usually don't display the full raw tables. Instead, what we often see are aggregated views. For example, the total sales by each category in the sample data table. You can see furniture with $300 in total sales, office supplies with $210 and technology with $190. This kind of aggregated data table is exactly what shows up on the Tableau canvas when we start building the visualizations. And remember, this aggregated view is also considered a table. Now, to really understand what a table calculation is, let's first look at what it's not. Take this aggregated table as an example. Suppose instead of these raw sales numbers in dollars, you want to see the value in thousands of dollars. So to achieve this, all we have to do is divide this sales column by 1000, creating a new column where sales are expressed in thousands. That's just simple mathematical operation or conversion based on each individual value. In Tableau, this kind of calculation is not considered a table calculation because conversion of each individual values doesn't depend on other values in the table. Now before we move forward, let's quickly note down the total sales across all categories, which comes out to $650. Now let's create another calculated field, this time to show the percent of total sales by each category. For example, for the furniture category, we simply take 300 divided by the total 650, then multiply by 100. That gives us 46%, meaning furniture alone contributes 46% of the total sales. Doing the same for the rest of the categories, office supply comes about 25% and technology makes up the remaining 29%. And that's how we build a new field called percent of total. Now this time, this new field percent of total is actually a table calculation. Why? Because computing a single value like this 46% for furniture depends on other values in the table. Without knowing this $210 from office supplies and $190 from technology, we couldn't have arrived at this 46% figure. I hope you can see the difference now. In the first case, we just displayed sales in thousands. It was simple standalone calculation. But here, with percent of total, the individual cell results depends on the whole table. So in a nutshell, we call it a table calculation when the new value we compute depends on other values already present in the table. I hope that's crystal clear to you now. In Tableau, we can achieve this kind of table calculation two ways. The first one is quick and default method using the quick table calculation feature. We have already seen this in few earlier videos. You just right click on this sales bill in the marks pane, choose quick table calculation and select percent of total from the predefined list. Here no manual formula or expression writing is needed. Since this video is dedicated to table calculation, we won't stop at this quick method. We'll also unpack the actual formulas, write our own table calculation using calculated fields, and break down each part of the formula so you understand exactly how it works. Now let's take another example to make this idea clearer. This time we'll stick with the same data table but add the purchase date field alongside the sales figures. In the sample data table, the sales are spread across 2 months, January and February. Now our task is to calculate the running total of sales so that for any given date, we can see exactly how much revenue has been generated up to that point. Sounds simple, right? We have already seen what a running total means in previous section videos. So to achieve this in Tableau, the first step is to drag the purchase date into rows and sales into the text. That will give us the day-wise aggregated sales table. By now, getting this kind of view in Tableau should be a snap for you. And as we know, the running total simply shows the total sales up to a particular date. So all we need to do is keep adding each day's sales to the cumulative total from the previous days. And that gives us a new field called the running total. Notice again, each value here in this new column called cumulative sales depends on multiple other values in the table, which is why running total is also considered a table calculation in Tableau. So with this example and the one before it, I hope the definition of the table calculation is now firmly engraved into your mind. And just like we talked about earlier, we can get this running total in two ways. Either by using the quick table calculation feature or by manually writing the formula to create our own table calculation. In this video, we'll explore both approaches. So let's kick things off with the running total table calculation. First, looking at the business ask behind it. Why exactly are we doing this analysis? Build our rough solution approach, and finally, Tableau implementation of our approach. So the very first question we are going to tackle is, how do we analyze the month-by-month breakdown of cumulative sales for each year? We'll first look at it in a table format and then turn it into a visualization that really makes an impact. And one of the reasons we are exploring this business question is revenue growth monitoring. How the money adds up month by month to see how sales are growing throughout the year. And another reason is trend comparison, which allows us to compare the sales trend with the previous year and catch any slowdowns early in the current year. And in terms of the fields we need, it's pretty straightforward. The order date field to pull out the year and month, and the sales field to capture the revenue. So to get started with the solution, the first step is to build a table that shows monthly sales for each year. Now since the ask is for a running total of sales, we'll create another field where for each month we keep adding sales up to that point. Starting from January to December, and remember, as soon as the new year begins, the cumulative total resets back to 0. So that's what we need to report first in a table. But if you read the question carefully, it also asks us to turn it into a visualization, something that can show year-wise trend much more clearly, which makes comparing years a lot easier. Now here I would suggest you to pause for a moment and think what kind of visual you would pick to compare running total for each year. Alright, so the best answer is a simple line chart. Here in this case, we'll plot the months on the x-axis and have 4 separate lines, each one showing the running total for the years 2019, 20, 21 and 22. Now in this plot, if you look closely at the data up to August, year 2022 leads with the highest cumulative sales of 365k, followed by 2021 at around 300k, 2020 at 224k, and finally 2019 with the lowest at 223k. In the same way, we can compare the sales for each remaining month of every year. And just so you know, in Tableau, this kind of plot is referred to as an area chart. So that's the idea and the solution approach we are taking for this simple business question. It may look simple, but while working through it, I'll show you some really useful Tableau features and terms that makes this kind of analysis much easier. So let's jump into Tableau and see it in action. So here in Tableau, the first step is to quickly set up this table structure that we talked about. So drag the order date field onto the row shelf and then click on this plus button to expand the date hierarchy until you reach the month level. And since we only need year and month, go ahead and remove this quarter pill from the row shelf. And there you have it, the table structure we wanted at the year and month level. Now next, drag the sales field onto the text on the canvas so we can see the monthly sales figures. Now to calculate the running total, head over to the sales pill in the marks pane, right click on the sales pill and go to quick table calculation and choose the first option, running total. This gives us a cumulative sales up to each month. Now that we have a running total field, let's also drag the actual sales field again to display the monthly sales for reference. Finally, just rearranging the sales pill so that the sales column comes first, followed by the running total column in this table view. Now let's take a closer look at this running total column. You can see the sales keep adding up month after month, which is good. But the moment we cross December, which is the last month of the year 2019, the sales in the cumulative sum column do not reset. They continue adding up. And this behavior goes on until the very last row in the dataset, which is December 2022, where the total sales reach around $2.3 million. Now let's go back to the question. Is this what we wanted? No, right? What we actually wanted to analyze cumulative sales by each year. So instead of adding up sales across every single month in the dataset, our table calculation needs to reset at the end of each year, just like we talked about earlier, right? So to control this behavior of this table calculation, we need to understand two quick concepts that allows us to set the limit and the direction of the table calculation and customize it the way we want. First, let's rename this sheet to running total all months and duplicate it so we can save some time. Next, let's clean up the canvas a bit by removing these two sales columns from the marks pane. Now before I dive into explaining the calculation flow and the direction, let's quickly create a row number field using index formula which we have already worked with earlier. Just create a new calculated field and name it to index. And inside the formula editor, just type index and hit OK. Finally, drop this calculated field onto the text area in the view. This will give us the row number or the index for every entry in the table. Now since we have 4 years of data, this corresponds to a total of 48 months. So the last row in the dataset has the index value or the row number 48. Also, let's rename this sheet to index for addressing. Alright, now the fun begins. The first thing I want you to notice is this index pill in the marks pane. Do you see this little delta or triangle symbol in front of it? Now what does that mean? Think about it. It simply indicates that this index field we created manually is actually a table calculation, right? Now think back to the table calculation definition we discussed a few minutes ago. Does it align with the definition of the table calculation? It definitely does. For example, take this index value of 6. Can we really know that it will be a value of 6 without knowing the value prior to it, which is 5? Exactly, we cannot. So just like the running total we just discussed, this index is also a table calculation because its value depends on the previous values in the table. Got it? Alright, now that we have established this, our next step is to control how this index calculation flows down the table. For this, Tableau introduces few terms called pane and table. Think of a pane as a big subset within this entire table. In our case, since the table is divided into 4 years at the top level, we can say that we actually have 4 panes here inside this entire table. And now what we need to figure out is to how to restrict the table calculation within each pane, meaning within each year. So the goal is to make sure that the index resets at the beginning of every year. So it starts fresh with each new set of months. Now that we know what's needed, we can easily tweak this behavior. Just right-click on this index pill in the marks pane and go to the option called Compute Using. This is where we set the direction and scope of this table calculation. If you look closely, the very first option is checked by default, which means the calculation is being done for the entire table in the downward direction. That's exactly why the index isn't resetting with each year. It just keeps numbering straight through until the very last row, ignoring the resetting at the very end of each year. And since we just discussed that a table has 4 panes, so instead of sticking with this table down option, switch to the second one, which is pane down. And once you choose the compute using pane down, the index now calculates only within each pane or within each year. This means the calculation resets at the start of every year, exactly as we want it. So now you know what to do if we want the running total to stay within each year, right? Exactly. We just need to adjust the scope of the table calculation. So let's try it out. So here, drag the sales field onto the canvas, right click on the sales field and go to the quick table calculation and choose the running total. Now by default, this running total is being calculated for the whole table as the default direction is table down. But if we right click on the sales bill and hover over compute using, and instead of this table down, just choose the option pane down, and the magic happens. The running total of the sales now resets at the end of each year. For example, by the end of 2029, the total sales in that year was around 484k. And as we hit the next month, which is January 2020, the cumulative sales just resets and just showing the total sales of the January 2020 month, which is only 18k. And this also makes the interpretation of this table super easy. For example, till September 2019, the total sales value in that year was around 304k. But in the 2020, by the same time, it is only 288k. This tells us that by September 2020, we are lagging behind as compared to the September 2019. This is exactly how we read and interpret this table. I hope this is making sense. So the first part of this analysis is done. We have created a table that displays cumulative sales for each year. But to compare months of each year clearly, like this September for each and every year, we need to create this area chart that makes the insights pop out. So just head over to Tableau and let's start a fresh new sheet and rename it to Running Total Area Chart. As you can see in this plot, the months are on x-axis. So first, let's drag the order field onto the column shelf. And to display all 12 months individually, right-click on the order pill there and select this first month option. Next, we need to drag the sales to the row shelf, and this will give us a line chart showing total sales for each month. But instead of just monthly totals, we actually want the running total, and that's too broken down by year. So right-click on the sales bill in the row shelf and go to the quick table calculation and select the running total. This gives us the overall cumulative sum of sales, which is as expected reaches around 2.3 million at the end. Now to split this into 4 individual lines, one for each year, we simply drag the order date field onto the color card in the marks pane. And that's it. We have year-wise running total trends in a single chart. But it's not very communicative just yet. Now it's time to switch this line chart into an area chart and add labels to make it more insightful, like the plot I showed you before. So first head over to this marks pane and open this drop down and choose this fourth option, area chart. And for the labels, just drag this sales field onto the label card in the marks pane. But remember, we want these labels to also reflect the running totals. Currently, it is showing the individual sales for each and every month instead of the running total. So right-click on the sales bill you just place on the label card and go to the quick table calculation, and here also select the first option, running total. And there you go. The chart now shows the cumulative values as area plots with labels. Let me quickly format this chart area, these numbers, to make it more presentable and more readable. Cool. Now let's again interpret this area chart by comparing the years at the same month level. Take this September for example. The cumulative sales till September 2022 are the highest at 453k, followed by 373k in 2021, meanwhile 305k in 2019 and only 288k in 2020, which is the lowest cumulative sales for September as compared to rest of the years. Can you figure out why it might be the case that the September 2020 has seen the lowest cumulative sales in that particular year? So the hint lies in the pandemic we faced in that year and prior to that. Awesome. So we have successfully built the analysis table and a visual that compares year-wise cumulative sales. And along the way, we covered concepts like index and pane. And if you have noticed, we created this index field manually that turns out to be a table calculation. But for this running total of sales, we simply used Tableau's predefined option from the quick table calculations list. So the Tableau's quick table calculation is super convenient because Tableau already knows that these type of calculations are used all the time in analytics. That's why they are called quick table calculations. But here's a thought. What if you wanted to build your own table calculation from scratch? Just like we built this index table calculation, how would you go about it in the case of this running total? Exactly, that's where the calculated fields comes in. Now my goal is to show you how to write and replicate these table calculations using calculated field, starting with this running total calculation. This will introduce you to more formula and expressions, but it will also give you a deeper understanding of how things work in Tableau and bring you a step closer to thinking like a Tableau developer. First, I'll duplicate this index calculation sheet where we have used this quick table calculation to solve the running total problem month by month for each year. Now let's rename this sheet to something like manual running total table calculation. So here RT stands for running total and TC stands for table calculation. Of course, you can name it whatever you like. I'm keeping it short since we will be creating a lot of sheets in this video. Alright, to get started with a formulative way of creating table calculations, let's go ahead and create a new calculated field and name it cumulative sales table calculation. And inside the formula editor, I'll be using Tableau's running sum function. And what do we put inside this function? It's simply the aggregate of that we want the running total, the sum of sales at the month level. So basically, inside this parenthesis, we just type sum of sales. And once we are done, just check the validity of the calculation and hit OK. Now the next step is to bring this newly created field onto the canvas. So drop it on the text and see how it works. Once that's done, I'll quickly rearrange the columns in the marks pane so that our manual table calculation shows up at the last column in the table. Now if you look closely at this pill, you'll again notice the little delta symbol. That's our confirmation that this cumulative sales field that we created is indeed a table calculation by default. And if we also check the values in this column, it's clear that the calculation is happening using the table down method, since it is not resetting at the end of each year, right? So how do we fix this? Exactly, just right click on this cumulative sales pill in the marks pane, and instead of this table down, switch it to pane down. And the moment you do that, the table calculation behaves exactly as we wanted, resetting after the last month of each year, just like the Tableau's default quick table calculation did. So now it's clear that quick table calculation aren't some mysterious shortcuts. They are basically just calculated fields built using specific formulas and expressions. And in this case, we have already seen one of those formulas in action, the running sum function over here, while computing this cumulative sales table calculation. Now when it comes to the formatting of this table, I'm sure you can handle the most of it on your own. But let me give you a quick tip. You can also rename these long column headers. So just right click on any of these column names and go to the last option that says edit alias and type in whatever name you want. Here I'm using this QTC, which means it is calculated using the Tableau's quick table calculation feature, and click OK. As simple as that. I'll leave this for you to try out. Now before we move on to the next business question and another table calculation, let's take this concept of pane and table a step further and unpack how table calculation behave in larger table where we have multiple dimensions. Now let's fully explore index, addressing, panes and partitions, concepts that makes the next business problem much easier to implement in Tableau. Let's begin with index and panes since they help us control the flow of table calculations. I'll first duplicate this index calculation sheet and leave the sheet name as it is. I've also dragged it right next to the area chart sheet. For now, I'll remove this running total so that we are only left with year, month and index. At this moment, the index is being calculated with the pane down option, which means it resets at the end of each year. Now let's break down the idea of a pane. To do this, I'll add one more dimension. Let's take region. Once region is dragged onto the column shelf, the table structure expands horizontally. So now we have year, month and region together in the view. But the key here is not the expanded table itself. It's rather how our table calculation, which is in this case is the index, is being computed within this new layout. Previously, it was computed using pane down, and still it is computed using pane down for every column in this new table. Okay, let's experiment a bit with different directions of table calculations in this new layout. So switch from pane down back to the table down, and you will see the index runs for all 48 rows in the table for each and every new column in the table itself. Now this time, let's try table across. This table across calculation should try to number each region from 1 to 4 for every month or every row. Let's try it out. Once you click on table across, this is what we expected. So for each month, which is each row in this table, all the regions are being numerically indicated from 1 to 4. So play around with this pane, table across and down combination and get comfortable observing how this number changes as we choose different types of computation directions. Alright, now if you have understood this, so for example, here I have chosen the direction using pane across and then down. So within each pane, first the table calculation will go across and then shift its direction downwards and then again go across. So for example, we start from 1, 2, 3, 4 going across and then go down and reach to the next row, which is 5, and then again go across 5, 6, 7 and 8. So this is how you understand these combinations and directions of these table calculations. Alright, this sets the stage for the next business question. We'll apply these table calculation direction concepts to solve the upcoming problem. Next up is a percent of total table calculation. You've seen it in pie charts before, but now we'll dig deeper. We'll build it manually and use it to tackle more advanced business scenarios. Let's start by looking at few cases business might be interested in when analyzing the sales data. Alright, so let's take the first scenario. Here, for every month in the dataset, what percentage of total sales is coming from each region? Just think through it, what is being asked over here. Sounds simple, right? So just for understanding, I suggest you first try creating a sample table schema of the solution yourself. Give it a go. Cool? Now why do you think this question matters to the business? Exactly, because it clearly shows which regions are driving sales in that particular month. Now the next scenario looks similar but is actually quite different. Here the question is, for a specific region, what percentage of total sales is contributed by each month in that particular year? Conceptually, it's important to differentiate these two scenarios. Pause for a moment and make sure you fully understood these questions before we move on. And now, why do you think the second question is important for the business? That's right, because it helps reveal seasonal or monthly sales pattern within that region. Think about it. Okay, now look at the last scenario. Imagine for a given year, we want to analyze the combined percent share of sales for a specific month and region. Again, take a moment to think about what's really being asked here. And this one's pretty important because it helps pinpoint the exact time and place where sales are either the strongest or the weakest. Alright, and if you think about it, by looking at these kinds of questions, we can clearly say that to get started with this analysis, we would specifically need to focus on fields like order date, region, and of course sales. Now, if you have carefully followed the last business case and these questions, one thing becomes quite clear. The very first step is to create a tabular schema that lays out dimensions like year, month, alongside the total sales for every region. For example, let's narrow it down for the year 2019. On the row shelf, we place the year and the month. On the column shelf, we place regions. And inside this area, we capture the total sales corresponding to that month-region combination. Once we have this view for all 4 years, we can tackle these questions one by one. Say for the first case, finding each region's percentage share for a specific month. Take example of this January 2019. We'll take the total sales and compute what percentage of this total sales comes from the East region, the South region and the West region respectively. So for the Central region, it will be 1540 divided by the total sales for all the regions, which is 14,237, and multiply this ratio by 100 to get the answer in percentage. So this we have to do for every cell for this first business problem, right? This means for January 2019, around 10.2% of total sales is coming from Central region alone. And this we have to do for every cell in this table for the first business problem. Similarly, for the second scenario, if we focus on the Central region and calculate what percentage of its total yearly sales comes from the January alone, so here the denominator changes. Instead of total monthly sales across the regions, now this time it's the total sales of the Central region for this year, which is around 103,838. So the calculation becomes 1540 divided by 103,838, and if we multiply it by 100, we'll get around 1.48%. So to interpret this, we can say that for the Central region in year 2019, around 1.48% of total yearly sales is coming in the January month. Making sense, right? And finally, for the last question, which is finding the combined percentage share of a specific month and region within a year, notice the denominator changes again. This time, the denominator will be 484,237 because this is the total sale of year 2019. So, in 2019, the total contribution from the Central region in the month of January will be 1540 divided by 484,247, and this comes out to around 0.32%. Got it? I'm skipping formal statistical terminologies here, but these same computation will appear in your probability and statistics course. So make sure your logic is clear. Perfect. Now let's switch over to Tableau and actually see how to perform these calculations. We'll build the required views, apply table calculation for percent of total, and then frame the results in a way that directly answers these business questions that we discussed. Alright, so in Tableau, let's go ahead and build this base table first. This table will display the total sales for each year, month, and region combination. And to make this analysis easier to follow, I'll show you how you can add these rows and column totals right on the margins of each pane. Now in Tableau, we already have this structure created. Now, since this is the same table structure we will use for percent of totals, the only difference is that instead of these numerical index values, we'll need the sum of sales. So let's quickly duplicate this sheet and rename it to percent of total. And the first thing in the sheet is to remove this index pill from the marks pane. And after that, just place the sales field here on the text card in the marks pane. With that, we now have an aggregated table in place that shows the total sales for each year, month, and region combination. Now, as I mentioned earlier, let's quickly add these rows and column totals to this table so we have all the values we need right inside it. To do that, head over to the analysis menu on the top bar and go to the totals. There you will see the first two options, show row totals and show column totals. Simply check them one by one. Once you do that, you'll notice the totals appearing on the right margin for rows and at the bottom margin for columns. But as we talked about, we need to show the region-wise total sales for each year after each pane, right? So to do that, let's go back to the analysis menu again and head over to the totals, and this time check this option which is add all subtotals. This will display the regional subtotals or the column subtotals within each pane. And for better clarity, you can also uncheck this column grand totals. This will make the view less cluttered. Awesome, this looks good. Now that our totals view is set up, the only thing left is to go ahead and run the analysis the business needs one by one using the percent of total table calculation. So for the very first question we'll tackle is for a specific month, what percentage of total sales is contributed by each region. For example, let's take this row for January 2019. What percentage of total sales is coming from Central region alone as compared to the rest? As we discussed, the denominator here is 14,237. And if you recall, in our earlier discussion on the direction of table calculation using index, this will be a percent of total table calculation with the direction set to table across, right? So go ahead and right click on the sales pill and go to quick table calculation and choose the percent of total and make sure that the direction of computation is set to table across. Now you will see the percentage share of each region for any given month in the dataset. So here in this highlighted row, which is the month of January 2019, the Central region contributes to around 10.82% of total sales in that month, while the South region contributes to around 65% of total sales in that particular month. And the lowest sales is coming from East region, which is only around 3%. Alright, this table contains lots of insights. So take time to interpret them and get comfortable using these findings in your report. And also notice how each row adds up to 100%. And here's where the row totals comes in handy. You can instantly understand what the table is showing just by looking at the row totals. Pretty convenient, right? Awesome. So that's all we needed to answer for our first business question. I've also pasted a snapshot of the table here in the slides, highlighting the direction of table calculation we used to bring it to life. Now let's move on to the next question, where for a specific region, we need to analyze the percentage share of sales contributed by each month in that year. Now, if you are following along, you probably guessed it already. This time, these column totals should add up to 100%. Let me show you what I mean by that. So for this second question, I'll be running the analysis on the same table. But before you move ahead, make sure to duplicate this sheet. That way all analyses stay intact without any overwriting or confusion. Now for this question, where we need to calculate the percentage share of sales for each month within the every region, I'll just tweak the direction of the table calculation. It's that simple. Now as I mentioned earlier, in this table, each year partition forms what we call a pane. So you tell me what should be the computation direction over here. That's right, the computation direction should be pane down, right? So just select the pane down and that's it. Very conveniently, we now see the column totals adds up to 100% within that particular year. For example, in this year 2019, the central region generated the most sales in the September month, contributing a whopping 33% of yearly sales. On the other hand, months like January and February had very low sales, each contributing less than 2% of total 2019 sales for this central region, right? So this is how exactly you interpret these insights and report such anomalies back to the stakeholders. Here again, I'm putting the snapshot of the final analysis table for the business ask, along with a note that this table was computed using the pane down direction of the table calculation. Alright, moving on to the next and final question. Now here, for a given year, we need to analyze the combined percentage share of sales for a specific month and region. Now since you have already explored almost all concepts of this table calculation, let's take a moment to think about how this question is conceptually different from the previous two. Exactly. Key difference here is that this time neither the column totals or the row totals should add up to 100%. Instead, it's the sum of all individual entries in this pane or in this year that should add up to 100%, as the denominator will be the total sales for the whole year, which is around 484k, right? Let's see this in action in Tableau. Now that you are familiar with the concept of direction, specifically pane and table, this time we are considering this whole year as a denominator. So we need to use this entire pane as a computation direction. So just right click on the sales bill again and choose compute using and click on the simple pane. And there you have it. Now all these entries in that particular pane or in the year will add up to 100%. Now let's quickly see how to read and interpret this table. Here, each individual entry is basically considering both time, which is month, and the location, which is region. For example, in 2019, the central region in the September month performed exceptionally well, contributing around 7% of total yearly sales, whereas East region in the month of February recorded almost negligible sales, which is quite concerning. I hope this example makes the concept clear. Once again, let's add the snapshot of the table to the slides with the computation methods we used. So this final slide provides a complete overview of each business question and how to interpret and compare them. Take a minute or two to quickly summarize the key findings from each analysis. So this is how we can leverage our understanding of quick table calculations and computation direction to tackle these business questions. I hope by now you're all feeling comfortable with everything we have covered so far. Now just like we manually computed the running total table calculation using the formula, I want you to quickly show how to create the percent of total table calculation manually with a calculated field. Ready? So the formulation and syntax of percent of total is actually quite simple. If you look at all these three types of calculation we just covered, you will notice a clear pattern. The numerator in all three cases is simply the aggregated sum of sales at the region and month level. while the denominator is a total of these sums. This is exactly the formula we will use in Tableau to create a calculated field that computes the percent of total. So let's go ahead and implement this in Tableau. The first step is to create a calculated field and name it percent of total. And inside this editor, type the formula we just discussed. That is sum of sales divided by the total sum of sales. Once that's done, just hit OK. Now to use this calculated field, let's first duplicate this sheet and rename it as manual percentage total table calculation. Next, let's remove the sales field from this marks pane and replace it with our newly created percent of total calculated field. You will notice that instead of showing percentages, the table is displaying decimal value. This is because this formula is simply calculating the proportion, and to convert this proportion into percentage, one way is to simply multiply it by 100. Now of course, there are multiple ways to convert these decimals into percentages. We could format the number directly or even edit the formula to multiply by 100. But I'll show you a smarter way to change the nature of this calculated field, which is percent of total, so that it always displays as percentages by default. To do this, just right click on the percent of total calculated field and hover over default properties. And then select the number format. And in the dialog box, choose the percentage and keep the decimal places at 2 and hit OK. Now you will see that all the values that were earlier in decimals are neatly converted into percentages. And the best part is whenever you use this calculated field in the future, it will always display as percentages by default. So no need to format the numbers every time you use this calculated field. Alright, also notice the pill in the marks pane and a small delta icon. Again, what does it mean? Right, it shows this is a table calculation. And because it's a table calculation, we can change its computation direction to answer all 3 business questions we just solved. Yes, we can. So take your time to experiment and try to recreate these same tables that we created before using quick table calculation. Alright, with that, we have covered all the details of the percent of total table calculation using 3 interesting and insightful business problems. Now let's move on to the next exciting table calculation, percent difference, and explore all its aspects step by step. Just like in the last section where we explored percent of total through multiple business questions, here too I'll introduce 2 business asks. We'll look at why the business wants us to analyze these, and through that process, we will learn about the percent difference table calculation, starting from the concept and moving all the way to the practical implementation. Cool? So the first problem the business wants us to analyze is that in a given year, which months recorded more than 100% sales growth compared to the previous month. Now pause for a few seconds. Make sure you have understood the question. Try to think through the raw mathematical logic behind what 100% sales growth actually means. Cool? And why do you think the business care about this? Exactly. Because this kind of analysis highlights the months with more than 100% growth compared to the previous month, which immediately points to sudden sales spikes, successful campaigns, new product launches, or even seasonal boosts. We'll dive into how to perform this analysis and interpret the results. In analytics terminology, this type of analysis is called month-over-month analysis, or simply MOM. Okay, now let's look at the next business ask. This time, the question is which months recorded more than 100% sales growth compared to the same month in the previous year. And unlike the first one, this is slightly different and holds a particular importance because it highlights months with more than 100% growth versus the same month last year. And this helps us track the long-term growth and make it easier to judge whether performance actually improved year over year. And if you've guessed it already, this type of analysis is known as year over year or YOY analysis in the analytics. Does it make sense? Awesome. So from these questions, it is clear that we only need two fields from the dataset, the order date and the sales column. So let's move into the approach and see how to deal with this. The first step is to build this base table that shows the monthly total sales for all years in the dataset. And the good part is we have already created this kind of table multiple times in earlier questions. So now let's take the first question, which is month over month analysis. So here we are essentially checking that how much sales for a current month, for example this July, differ from the previous month, which is June in this case. Now think about this. If you consider the very first month in this dataset, which is January 2019, do we have sales data for any month before this very first month in our dataset? Of course not, right? And that's why we cannot calculate the percent difference for the very first month. But starting from February 2019 onwards, we do have the previous month's data, which is January 2019. So from there onwards, the percent difference in sales can be calculated for every month in this dataset. Does it make sense? So that's exactly why when we run MOM analysis, the result will start showing from February 2019 onwards. Alright, now let's get to the simple maths behind these percent differences. To keep things clear, I'll show you the calculation for this very first percent difference we see in our table, which is minus 68.25 for the month of February 2019. The rest you can easily follow along with the same method. So the formula is straightforward. We take the difference between the current value and the base value, which is the previous month's sales, and divide the difference by the base value. And finally, to express it as a percentage, we multiply the result by 100. And that's it. Now let's plug in the actual numbers and see how this first MOM figure, minus 68.25, is computed step by step. So let's apply the formula to our first case. So for February 2019, this current value is basically the sales for this February 2019 month. And that is simply 4520. And the base value is January 2019 sales, which is 14,237. Now we subtract the January sales from the February sales and divide by the base value, which is January sales, and finally multiply it by 100. And since the denominator difference is negative, that's why we are getting the percentage change to be minus 68.25. In simple words, sales in February dropped by 68.25% as compared to the previous month. And that's exactly how we compute and interpret the month-over-month percent difference metrics for the rest of the months in the table. Alright, now let's shift to the second question and talk about year-over-year analysis, or YOY. Now unlike the month-over-month, which compares sales to the immediately previous month, year-over-year compares the sales of a month to the same month in the previous year. So for example, to know how January 2020 sales performed as compared to the January 2019 sales, we can simply plug these two values in the percentage change formula and get the result. If you want to know how the January 2019 sales performed compared to the January 2018 sales, we would need January 2018 sales data. But since January 2018 sales data is not available, we cannot compute the YOY for January 2019. Or in fact, we cannot compute the YOY for any month of the 2019 year. So that's why the very first year-over-year calculation we will be able to perform will start from January 2020 onwards. Because now we can compare this January 2020 sales against the January 2019. Make sense? right? So this logic is a simple foundation of the year-over-year analysis. Alright, now let's quickly walk you through how the percentage change formula is applied for YOY calculation. Take this first value. For January 2020, the year-over-year growth is 27.65%. And let's see how this value was computed. Now, if we use a formula of percentage change, the base value will be January 2019 sales, which is 14,237, and the current value is January 2020 sales, which is 18,174. So we subtract this base value from the current value and divide this difference by the base value, which is 14,237. The result is a positive 27.65%. That means this January 2020 saw a 27.65% increase in sales compared to January 2019. Clear, right? This is exactly how you compute and interpret year-over-year percent difference. Now pause here for a moment. Review the formula and make sure you're comfortable with the logic behind both month-over-month and year-over-year calculations, and why it is important for any business to track these metrics before we jump into the Tableau implementation. Alright, now let's switch to Tableau and walk through the technical implementation to quickly solve both of these questions. Now here in Tableau, let's create a new sheet and name it as Percent Difference QTC. As you already know, that QTC stands for Quick Table Calculation. We'll first solve these questions using Tableau's built-in Quick Table Calculations, and later I'll show you how to create your own formulas with calculated fields to compute MOM and YOY respectively. First things first, let's quickly build this year monthly sales table just like we have done before. So simply drag the order date field to the row shelf, keep clicking on these plus buttons until you drill down to the month level, and then drag out the quarter bill for now. Next, drag the sales onto the text card or directly on the text area on the canvas. This simply gives us the base table with monthly sales displayed. And now we are all set to start the analysis. Once we've understood this logic, performing month-over-month or year-over-year analysis in Tableau becomes quite straightforward. Simply right-click on the sales bill in the marks pane, hover over Quick Table Calculation, and select the percentage difference. Now by default, this table calculation computes the percentage change for consecutive rows, which in our case represents the month-over-month change, right? And as you will notice, the computation begins from the second month onwards, since the first month does not have a previous value to compare with, right? Now let's create a column for year-over-year percent change. To do this, again drag the sales field onto the canvas, and just like before, right-click on this new sales bill in the measure value pane, go to the Quick Table Calculation, and notice Tableau has a dedicated option called year-over-year growth, which is a second from the bottom. Just click on that and Tableau will compute the year-over-year percentage change in this last column. And as expected, the year-over-year value starts from January 2020 onwards. Since for the January 2019 computation, we don't have any data from January 2018, right? Now for aesthetics, we can also keep the actual sales figure visible by dragging the sales field one more time onto the canvas. Now I'm reordering the columns by rearranging these pills over here so that the sales comes first, followed by MOM and then YOY column. And finally, just like I told you before, you can rename these default headers for clarity. Just right click on these headers, choose Edit Alias, and since this is MOM calculated using Quick Table Calculation, so I'm renaming it as MOMQTC, and simply this field as YOYQTC. You can also adjust the width of the table or columns as per your liking. Awesome, there you have it. This is the exact table our business wanted us to analyze. Now it's up to you to interpret this table just like we discussed earlier in the theoretical part, and extract the key insights and put that into a final report. Remember, these insights are what you will present to your higher management, and they directly influence important business decisions. Alright, so that's how you use the percent difference quick table calculation to compute two important business metrics, which is month over month and year over year percent change. Now let's take it a step further and really dig deeper. So just like the previous table calculations, here also we'll uncover the core formulas and logic behind these quick table calculations and see how to manually create these calculations without relying on Tableau's quick table calculations shortcut. Excited? Well, I definitely am. Now let's translate this percentage change formula into Tableau's formulation step by step for both month over month and year over year. Starting with month over month and using February 2019 as an example. So if we try to translate this mathematical formula into Tableau's expression, it's simply sum of sales of the current month minus the sum of sales for the previous month divided by the sum of sales of the previous month. Here base value is basically the sum of sales of the previous month. Straightforward, right? Now if we take this February month as a reference point and assign it as a position 0, so the month before this reference month can be placed on a negative integer scale and the month after that reference month can be placed at the positive integer scale. So this way every month get a relative position around the chosen reference month, making it easier to define which month is the previous one and which month is the next one for the calculation. Now you can simply tell that what should be the index or position value of the previous month in this formula. Exactly, it's -1. So when we say sum of sales for the previous month, what we're really doing is looking up the sales value at position equals to -1 with respect to the reference month at the 0th position. So in Tableau, we can simply replace this previous month sales with a lookup function which fetches the sum of sales value at the -1 position relative to the current month or the reference month at the 0th position. Makes sense, right? So it's actually quite simple and intuitive once you understand these positions with respect to the reference month. So this is the final formulation or expression we will use in Tableau to create a month over month calculated field or the month over month table calculation. So pause here for a moment and be sure you're comfortable with this Tableau syntax for calculating this month over month change. Now if we shift our focus to year over year change and take inspiration from this month over month calculation, you probably already guessed where the tweaks needs to happen. Exactly. So the logic stays same, but instead of looking only 1 month back, we need to look back 1 year, which is basically 12 months back in this month level table. So keeping this small adjustment in mind, let's understand the formulation for year over year change. And since the year over year calculation starts from the January 2020 onwards, let's take that as a reference month for now. And here's the key point. If we want to calculate the percentage change compared to the January 2019, which is exactly 1 year earlier, we need to look back 12 position up in the table, which is at the -12th with respect to the reference month. So that means our lookup index will be -12, right? So for the year over year percent change formula, we'll just adjust this lookup function, and instead of fetching the base value at -1, here we will fetch the value from -12th index relative to the reference month. And that's all there is to it. So this is the final formulation and expression percentage change in Tableau. So in Tableau, we'll now take these final formulas and create two calculated fields, one for MOM change and another for YOY change. Sounds good? Then let's jump right into Tableau and build them out. Now here in Tableau, since we've already completed this month over month and YOY analysis using quick table calculations, I'll simply duplicate this sheet and build our new MOM and YOY fields using the calculated field formulas right here for the quick comparison. So that way we can validate whether our formulas are giving exactly the same results as the quick table calculations. Let me close this dialog box for now and rename this sheet to percent difference table calculation using formulas. Now first, let's compute the month-over-month percent difference using the formula we just went through. So create a calculated field and name it as percent difference MOM. And inside the editor, type in the same MOM formula as shown on the screen. Once done, validate the calculation and hit OK. Now instead of calculating a fresh calculated field for year over year, I'll simply duplicate this MOM field and rename it to %diff YOY. And inside the formula editor of this YOY, I'll just tweak this lookup function, changing this -1 to -12 so that the base value shift to the last year's month sales value. Finally, click OK, and that's it. We have successfully created both MOM and YOY table calculations manually. Now all we need to do is to drop these new fields into the visualization area. So go ahead and drop these calculated fields one by one onto the text area on the canvas. Now as soon as you drop the both fields, you might notice something unusual. The perfect integers showing up. You may wonder if something's wrong with the formula, but don't worry, the calculation is just fine. What's happening is just a formatting issue. By default, the field displayed are just fractions or decimals, and the values are getting rounded off to the nearest integer. To fix this, we simply change the formatting of these fields. So let's start with the MOM, right-click on it, go to the default properties, then click on number format and select the percentage and keep it to 2 decimal places and hit OK. And do the same for the YOY field. And if you'd like, you can also tidy up the column names by editing their alias, maybe shortening them a bit. And that's it. I'm also rearranging the pills in this measure value so that both MOM fields using the quick table calculation and the formula appears side by side. And same goes for the year over year fields as well. Now you can clearly see that both the MOM fields we created using the formula and the quick table calculation and the year over year fields calculated using quick table calculation and the formula are giving the exact same results. This shows that we have not only mastered Tableau's built-in table calculation shortcuts, but also the flexibility of calculated fields to build our own custom logic and formulas. And the beauty here is that these formulas are adaptable. You can always change the base month simply by adjusting these index values according to the business requirement. So for example, instead of comparing this January 2020 sales with January 2019 sales, you could check how January 2020 performed against June 2019. All you'd have to do is to adjust the lookup index, which is -7 in this case, so the calculation fetches the June 2019 sales as the base value. This flexibility lets you answer very specific business questions depending on what time period the stakeholders want to compare. I really encourage you to experiment with this and see how changing the base month impacts the calculation. And most importantly, make sure you are interpreting the numbers correctly after making any adjustments. Now it's your turn to practice and master these concepts thoroughly, both from the theoretical side and the technical implementation side in Tableau. Cool. So here we have covered month over month and year over year change. But as you gain more analytical experience, especially in finance domain or when analyzing business growth indicators, you will run into a few other key percentage change metrics. These includes YTD total, compound growth rate, YTD growth, all of which you can also find under these quick table calculations. So here's a small homework task for you. Work out the mathematical formulas for each of these calculations on your own after watching this entire video and try to understand what sort of insights each of these metrics convey. Alright, so that's all I have for this section on percentage change table calculations. Now let's move ahead with another interesting table calculation called rank and explore the kind of business cases we can quickly analyze using rank calculations. As the name suggests, the rank table calculation assigns an integer rank to each entry in the table based on its measure value. And the concept and implementation is also pretty straightforward. Let's dive in with a simple business analysis example, where for each year, we'll identify the top 3 months with the highest sales and also the bottom 3 months with the lowest sales and rank them. Now before we jump into the solution, let's talk about why this analysis matters for a business. So when we identify the top 3 months with highest sales in each year, it helps in pinpointing the peak demand periods. And that also helps the business focus on marketing, promotions, and inventory during those high-performing months. And spotting the bottom months with the lowest sales is just as important. Basically, it highlights weak demand periods that could guide strategies to boost sales, or maybe cut costs during those slower months based on their poor performance ranking. These are just some basic reasons a business might ask for this kind of analysis. So as an analyst, you should always remember to think from the business's perspective. And you can also come up with more points or insight that could add value to their decision making. So with that in mind, let's look at a solution approach that shapes this analysis. Now, first step, as always, is to identify the required field for this analysis. And from the question itself, it is very clear that we only need order date to fetch the year and month and the sales field. And again, since we are analyzing monthly sales per year, we can stick with the base table we created earlier in previous business analysis questions. Now the next step is to create a rank field that uses a table calculation that ranks each month within its respective year. Simple, right? So to identify top and bottom performing months by sales, we'll simply add a filter slider. This slider will help us refine and shape the final view of the analysis. Basically, when we set the slider window to a minimum of rank 1 and a maximum of rank 3, we are showing the top 3 months for each year based on sales. Similarly, to display the bottom 3 months, we just move the slider and set the minimum to 10 and maximum to 12. And that's how the complete approach and final solution comes together, right? So our first task is to fill this rank field for each year or pane in this base table. In Tableau, I'll start by showing you how to set it up using the quick table calculation first. And just like other calculations we covered earlier, I'll also walk you through creating a custom calculated field to compute the rank manually. Alright, let's jump into Tableau and quickly set this simple rank table calculation to wrap up this analysis. Once you are in Tableau, we can start by duplicating this sheet and rename it to 4 rank QTC, where you already know that QTC stands for quick table calculation. And since we only need this base table, we can get rid of all these 4 fields by simply dragging these fields out from the measures value pane. And simply drag the sales field again onto the text card or the text area on the canvas. Now from here, we just have to rank each month within its year based on these total sales values. To do that, just right click on the sales field, go to the quick table calculation and click on rank. Now just like the index calculation we covered earlier, this initially ranks all months across the entire table. So you'll see ranks going well past the expected maximum value of 12. Now all we have to do is to limit this rank to the pane only or for each year. And you know very well how to do that. Simply right click on the sales field again, go to compute using and select the pane down direction. Now you can see each month is correctly ranked within its own year by the total sum of sales. Let's also place the sales field right next to the rank field so both the sales and the ranks appear side by side. And if you prefer this sales field to appear before the rank column, just reorder the pills in the measure value pane. Looks good, right? With this, we have taken the first step towards identifying the top 3 and the bottom 3 months within each year. Now to create this final reporting view that shows only top 3 or bottom 3 entries, we'll simply add this kind of a filter slider. So in Tableau, just right click on this sales field that is used as a table calculation to compute the rank and simply click on the second option that says show filter. Your filter slider now appears on the top right, ready to adjust the rank range. Perfect. Now if we set this rank filter slider minimum to 1 and maximum to 3, this instantly shows only the top 3 sales months for each year. Now if you observe closely from this filtered view, a clear pattern stands out. Every year, September, November and December consistently dominate in total sales. Now I want you to give a thought and come up with the reasons why this might be the case. Cool? So a likely reason is due to festive shopping season and the year-end Christmas or a New Year period. Basically, all drives higher consumer spending. You can also dig deeper by checking promotions or discounts that brands offer during these festivals. Or you can find other reasons, whether there is a quarter-end financial year push when companies target revenue goals, or is it simply due to seasonal demand cycles like pre-winter purchases. Basically, exploring these angles with additional business datasets like marketing campaigns, inventory records, or macroeconomic indicators will help confirm why those months stay on top each year after year. So the Tableau implementation of this rank calculated fields is straightforward, but here's the real takeaway. The real skill is uncovering the why. A professional analyst doesn't stop at showing a chart or this report. You need to dig deeper into internal factors like marketing campaigns, pricing, strategies, or inventory cycle, and external factors such as festivals, holidays, or marketing trends that create these repeating patterns and correlate them that why we are seeing such repeating months every year. Then wrap those findings into clear, story-driven narrative for higher management or stakeholders. And that storytelling is what turns raw numbers into actionable business insights. Alright, enough talk. Now just like we did for the top performers, you can simply slide the filter so that the minimum value is 10 and the maximum is 12. This instantly shows the bottom 3 month sales of each year. Here also, notice how January and February keep showing up at the bottom every year. Now your task again is to simply pause and think through it. You could come up with few possible reasons like some seasonal demand dips, post-holiday slowdowns, or other business-specific factors. Basically, dig in and list those reasons. Because uncovering why these months consistently underperform is just as valuable as spotting the pattern itself. Now here we use the quick table calculation to create this rank field. And you have probably guessed what's next. Now I'll show you how to manually build the same rank field using a calculated field with a formula expression. So first, I'm going to duplicate this sheet and rename it as rank using formula. Next, remove this pill in the marks pane that's using the quick table calculation for the rank computation, and also get rid of this slider by clicking on this small drop down and selecting remove filter. So basically we are left with just the base table showing monthly sales. Now let's manually create the rank table calculation. First, we create a calculated field and name it the rank by sales. And in the formula editor, we just type the rank function, and inside it, we'll use the monthly sales. So basically, the aggregate is sum of sales. Now before you click OK to finish, you can take a moment to glance at this rank function documentation. And once I type the rank in the search field, you can see there are various versions of rank available over here. But we are using the simple rank field or the vanilla rank field in the editor. Now as a quick homework activity, read up on different rank functions available in the Tableau like rank dense, rank modified, rank percentile, rank unique. All these functions have utility in different scenarios. But we only need the simple rank function here. But it's good to understand these advanced ones for different type of scenarios later into your analytics journey. Alright, to finish up this calculation, just click OK and let's start using this calculated field we just created. To display the rank using this custom calculation, drag this rank by sales field onto the canvas. Again, you will see all 48 values ranked in descending order. Highest sales get the lowest rank and lowest sales get the highest rank. That's what we wanted. I'm also reordering the fields so the sales column appear first. Here too, notice rank calculation is still considering the entire table, not separating by year, right? And we already know how to fix that. Just right click on this rank by sales field in the measure value pane, hover over compute using and select the pane down option. And that restricts the rank computation to each pane or each year. And finally, just like the last sheet, right click on this rank by sales field again and click on show filter. This again displays the filter slider at the right top of this canvas. Now you can start analyzing by adjusting the slider position to match the analysis we are aiming for. And that's it. You will see the exact same results we got earlier when we used the quick table calculation. Awesome. That wraps up the rank table calculation, which was simple to implement and easy to interpret. Now let's move on to the final table calculation for this video, moving averages. This one is a favorite and critical for understanding time series data and is often used in finance and stock market analysis to spot trends and make basic future predictions. So that's why we'll spend a good amount of time on theoretical understanding first, using some cool visualizations, illustrations and charts, and then dive into how to implement it in Tableau, both using quick table calculation and doing the scratch implementation using the formulative approach. So stay tuned, things are going to get interesting. To kick off with moving average discussion, let's first build the conceptual foundation through an easy to follow example from the stock market. Imagine you are tracking the end of day stock price of your favorite company for 10 consecutive days. Now to visualize this, we can place the days on the x-axis and share price on the y-axis. This may give us a clean line chart showing the stock price for each day. For example, in this 10-day period, you can clearly see that the lowest price was 220 and the highest price reached by this stock was 390. Now before we dive into the maths and concept behind moving averages, let's first understand why this analysis is useful and what insights it can bring on the table. Looking at this simple line chart that shows the day-by-day stock prices, can you tell what the trend is? So by trend, I mean whether the overall prices are generally moving upward, downwards, or staying mostly flat. If you observe closely, we can roughly imagine that for the first 7 days, the prices drift a bit downwards, and after the 7th day onwards, they start moving upward, right? Now when I sketch this rough overall trend as a green line, notice how we are not focusing on every little spike or dip in this purple line. In other words, this green line represents a smooth version of the actual price movement, telling us a clean view of the general direction in which the stock prices are moving. Make sure you're clear on this intuitive idea. This smoothing intuition is really important to grasp before we dive into the actual moving average calculations. And that's exactly what a moving average does. It captures this smooth green line precisely that we just sketched out, basically showing the long-term trend in the daily stock prices. If you can spot this overall direction in which the stock prices are heading, it can definitely guide your investment strategy and help you make smarter decisions, right? So that's the key importance of moving averages as a table calculation. Now let's dig into the mathematical intuition behind what a moving average actually means. Now, as the name suggests, moving average means we are computing an average that keeps shifting. Let's break that into two simple parts. What do we mean by moving and what do we mean by average? Now, To calculate an average, we need at least 2 or more values, so that we can add up the values and divide by how many numbers are there, right? So let's say we start with the first 3 days price to find their average. And for the next average computation, we then move the window of these 3 numbers forward by 1 day at a time, always taking the next set of 3 values to compute the next average. If the simple procedure makes sense to you, then it's awesome. If not, no worries. Let's walk through it in action, one computation at a time. So here, for the first calculation, our 3-day window covers the stock prices for the day 1, day 2 and day 3, which are 290, 350 and 310 respectively. We first take this simple average, which is about 317, and plot this 317 as a green dot on the chart at the day 3. Simple, right? Next, we slide the 3-day window forward, so it now covers day 2, day 3 and day 4. Again, taking the average of those prices gives us about 313, which we mark as another green dot on the chart on day 4. And we keep repeating this same process until the day 10. So by day 5, the last 3 days average comes out to about 300. For day 6, it is around 305. Day 7 gives us about 285. Day 8 is roughly 263. Day 9 comes out to about 268. And finally by day 10, the last 3 days average is about 325. I hope you're following this simple visual calculation without any trouble. And that's exactly how we calculate moving average with a sliding window. In this example, we used a 3-day sliding window, but the window size can vary depending on the application and the data. And as I mentioned earlier, that a moving average captures the general trend or the direction of price movement by smoothing out certain spikes. That's exactly what you will see here. If you connect all these green dots representing a 3-day moving average, the overall trend becomes clearly visible. And that's the real power of moving averages. So before we move on, take a moment to pause and absorb everything we have covered about moving averages so far. What they are, why we need them, and how we compute them. If needed, rewind the last few minutes of the discussion and try to answer the simple question I'm about to ask. So here on the plot, you see 2 lines. One is base purple line showing the daily end of day stock price, and other is the green dotted line we just calculated representing the 3-day moving average. Now, which of these lines do you think provide better insights for making investment strategies for the next day or for few days ahead of day 10? It's important that you answer this question in your own words before proceeding further. Sounds good? Alright, this was a simple example to give you the basic idea and fundamentals of moving averages. Now let's look at a real-world visualization from the stock market data. In this plot, you can see how a stock's daily price fluctuates over a 12-month period. The daily prices shows plenty of variability, sudden peaks, valleys, and sharp spikes, which makes it hard to clearly see the long-term trend or the overall direction of the stock. This is exactly where the concept of moving average helps. The moving average smooths out those rapid ups and downs, revealing the underlying trend. Here this blue line is simply the 50 days moving average plotted on the same chart. Now to answer the question that I asked in the previous slide more comprehensively, taking this real-world plot as a reference, a simple moving average removes short-term noise. Basically, it smooths out sudden spikes or dips like holiday sales or one-time event. So the underlying trend becomes much clearer. And that makes you a smarter investor by enabling better decision making. The moving average gives you a more stable view of performance and helps you plan around long-term patterns instead of reacting to short-term fluctuations. I hope with this real-world example, the importance of this moving average concept should be crystal clear to you. Later, as you progress, we'll revisit moving average in the machine learning course as well. There we'll apply them to time series data to build predictive models that forecast future outcomes from historical trends. So stay tuned. Alright, now let's explore how we can apply the moving average concept to address the business problem at hand using this superstore sales dataset. First, we'll understand the approach and then we'll look at the detailed technical implementation in Tableau. So the task here is pretty straightforward. We need to look at our sales performance using a 3-month moving average to spot the real trend. Why should business bother with that? Well, for one, it gives a clear picture of how monthly sales are actually moving because it smooths out those short-term ups and downs. And secondly, it makes the insights more reliable. So instead of getting thrown off by sudden spike or drop in monthly sales, management can focus on steady pattern and plan strategies around that. Make sense? And for performing this analysis, we simply need 2 fields, that is order date and simply sales. Alright, so this is the final table we are trying to build, and then we'll turn it into a line chart. But before jumping into that, let's break down how we actually get this table and what these numbers really mean. This part of table is the one we have built a few times already. But this specific field, the rolling or moving average of the last 3 months sales, is something we need to focus on. In other words, each number here is the average of the last 3 rows. Let's see what we've got here. Now when we calculate a 3 months moving average in Tableau, by default it tries to include these first 2 values as well, which isn't really correct and ideally should be null because we don't have enough data to form a 3 month window yet. That's why we just skip or don't focus on the first 2 values. In Tableau, I'll show you how you can make these values null when we don't have sufficient data to compute the average. Okay? So to read it correctly, we'll start from the 3rd row of the moving average column. Make sense? So that means this 24,816 is the simple average of the first 3 months sales. Likewise, this next 29,502 is the average of the following 3 months sales, February, March and April. You can even double check it yourself with a basic average formula to check its underlying calculation. And that's basically how you read this field. Here, each number represents the last 3 months moving average. So this is our very first goal for this analysis that we'll be putting together in Tableau. Now there are quite a few little details when we try to build this calculation manually using Tableau's calculated field. But before diving into all those nuances, let's first see how we can calculate these moving averages in Tableau using the built-in table calculation feature. Now in Tableau, let's quickly set up this base table that displays the monthly sales for each year. So to start, create a new sheet and name it as Moving Average Quick Table Calculation. And here, let's build the base table. Once we have this base table ready, now let's convert this sales column into a moving average quick table calculation. So just right click on the sales bill in the marks pane and go to the quick table calculation and choose the moving average. And for clarity, let's also put the actual total sales for each month by simply dragging the sales field onto the canvas text area. As always, just reorder the pills so that the sales column appear first in the table for a cleaner view. Now let's check how Tableau has computed this moving average column using the quick table calculation. So to do that, just right click on the sales bill that holds the moving average quick table calculation and this time choose the edit calculation to see the exact setting Tableau used for computing this moving average calculation column. Now let's pause for a moment to understand what we are looking at. This window is the core of quick table calculations. Here you can customize how these quick table calculations work. In the first section, which is calculation type, this drop down is set to moving calculation, which is exactly what we need. From this, you could also pick other quick table calculations that we have covered earlier and adjust these settings as needed. Now when you open the next drop down, a small dialog box appears. And in this drop down, you can pick the aggregation type. So for calculation type, which is moving calculation, you can choose to compute something like moving sum, moving minimum, moving maximum, or simply moving average. And since we are after moving average, so just select the average over here. Also, before adjusting these previous values and the next value settings, look at this last checkbox that says null if there are not enough values. First, check this box so that the Tableau leaves these two cells blank where there isn't enough data to compute a 3 months moving average. Something that I told you earlier in the slides. Now let's break down what these previous and next value settings actually mean. Remember the idea of relative positions we discussed in the percent difference section? So basically, here the current month, this March 2019, is treated as position 0 because moving average computation is starting from this row. And that's our current value. And 2 months before it, January and February, are the previous two values before the current value. So with this default setting, Tableau includes the sale of the current month plus the sale of two previous ones. So it's basically averaging 3 values. If you can relate, that's exactly the 3 months moving average we talked about. Now here's a quick experiment for you. Try to uncheck this current value option and see what happens. A quick hint for you, it will change how the average is calculated. So manually check a few numbers to confirm the effect before finalizing. Take this as a quick homework exercise. Also spend a couple of minutes exploring this Edit Table Calculation dialog box. Play with options like compute directions along a specific pane, adding a secondary calculation, and so on. Try unchecking or tweaking different settings to see how results change. Spending a few minutes with these options will help you really understand how to edit these quick table calculations effectively. Awesome, now go ahead and close this. So thanks to Tableau's Edit Table Calculation feature, we can clearly see that this new field was created with a moving average calculation is simply a 3 months moving average, just like we talked about in a solution approach, so we don't have to tweak any settings over here. Alright, now following the same template we used for other table calculation in this video, I'll walk you through creating a calculated field from scratch to build this moving average calculation. We'll use Tableau's own function and formulas so you can see exactly how it works. And along the way, we'll pick up a few more Tableau school formulas and data analytics concepts. Let's dive in. We'll begin with a quick revisit of the very first table calculation we covered, which was running sum of sales, right? Where we simply kept adding up the sales month by month. For example, till this first month of January 2019, the running total is just the month sale, which is 14,237. Until February 2019, we added January and February sales, so it becomes 18,757. And we keep accumulating this way. By the end of the year, the running sum of all 12 months reaches 484,247. Pretty straightforward, right? This illustrates the cumulative sales up to each month. And we implemented it in 2 ways. First was quick table calculation using Tableau's built-in running total option. And the second was the manual method by creating our own calculated field to compute the running sum using this running sum formula. But now, let's say instead of adding up all the months every time, imagine we just want the total of the last 3 months. It's kind of like a moving average, but here we call it a moving sum. Now let's see how would we write the formula for this moving sum. If we can figure this out first, extending or modifying this moving sum formula to moving average formula will be super easy. So to understand how the moving part works in a formula, Tableau gives us a special set of functions called window functions. So let's start by looking at the window functions that we can use for creating this moving sum. Here we call it a window sum. So here's what's happening. We've got a sliding window of 3 months. And for each window, we add up the values inside it. So for the first 3 months, January, February and March, the total comes out to about 74,000. Then we slide the window down by 1 month. Now it covers February, March and April. And the sum of this set is roughly around 88k. And as we keep sliding the window forward 1 month at a time, the moving sum calculation always shows the total sum for just that 3-month window. So by the final month in this small table, it's only summing October, November and December. And that's about 179k. Makes sense, right? Now notice the difference here. With running sum, there is no sliding window at all. It just keeps adding everything up from the start. But in the moving sum, we use a 3-month sliding window to total only those specific months. Now let's use the same table to break down the formula for the moving sum. Here the main formula is the window sum function, which needs 3 inputs. First, the measure you want to sum. Here it's simply the sum of the sales. And second, the starting position of the window. And third, the end position of the window. And to figure out the start and end positions for a 3-month moving sum window, let's take this June month as an example. Here we treat June as a reference month and give it a position 0. Therefore, all months before June get negative integer positions and all months after June gets positive integer positions relative to the June. So if we are using a 3-month sliding window here, June is the end month and the April begins the starting month of this window. Now it's easy to assign the relative positions, such as April is at -2 and June is at the 0th position. That means for a general 3-month moving sum, the start position is at -2 and the end position is at 0. And that's exactly what we would use to create a calculated field for the moving sum table calculation in Tableau. Makes sense, right? Awesome. So if you have understood this, then moving average is just a simple extension of this moving sum formula. So here in the next slide, I'll keep this as a reference and explain the formula for the 3 months moving average window. So for a 3 months moving average, we are simply taking the sum of first 3 months in that window and dividing it by 3, which gives us an average value of 35,878 and moving the window forward for the next calculation. The only change in the formula is swapping this window sum with the window average function while keeping the same start and end positions. And that's it. This is the final formula to manually create a moving average table calculation in Tableau. Easy, right? I told you it would be simple. In Tableau, we'll create a new calculated field, apply the moving average formula we just discussed here, the moving average table calculation. And then we build a visualization chart to see how the moving average smooths out the monthly sales trend. Alright, it's showtime. Now here in Tableau, let's first duplicate this current sheet, which is the moving average quick table calculation, and rename it to moving average using formula. Here we will compute the moving average using manual formula that we have just discussed. So the very first thing I'm going to do is to remove this moving average field which used quick table calculation to compute this column. So just simply drag out this table calculation from this measure value pane that leaves us with this base monthly sales table. Now let's quickly create a new calculated field and name it as window average of 3 months. Here 3M simply stands for 3 months, but you can choose any other name you like. Inside this formula editor, enter the formula we discussed in the slides here. Window average, the first argument is sum of sales, the start position is at -2 and the end position is 0. And that's it. Make sure the calculation is valid and click OK and you will see this new field appear in the data pane. Next, drag this new field onto the canvas and observe the change. If you compare this column with the quick table calculation, you will see it's computing the exact 3 months moving average we wanted. Now to handle these first two values in this moving average column here, which aren't true 3 months average due to limited data, just right click on this table calculation pill in this measures value pane and select the edit table calculation. And here in this dialog box, simply check this first option null if there aren't enough values. And this will get rid of the first two values which aren't the true representative of the 3 months moving average. And finally, you can close this dialog box. And that's it. So this is how you can manually implement the moving average table calculation using a formula. Knowing the formula approach always gives you more control over Tableau's functionality and moves you a step closer to becoming a Tableau developer. So be sure you're comfortable working with these kinds of formulas. Okay? Now let me ask you a quick question. This one's simple if you have been paying attention. Here, let's take a close look at this window average 3M pill in the measures value pane. Notice this small triangle icon that shows it's a table calculation? Now this is just a manually created calculated field. Then why is it a table calculation? I've told you this multiple times in this video. Now take a pause and think. So basically the hint is in the definition of the table calculation we covered at the start of the video. If you're unsure, rewind the first 5 to 10 minutes and review what makes this calculated field a table calculation by default. Great. Now that we have gone through all parts of our moving average table calculation, let's quickly create a line plot visualization to depict our insights and findings from this table that we have created using moving average. In the line chart, we'll first show this actual monthly sales data trend and add another line to highlight this moving average, just like the examples we looked at earlier when discussing the theoretical details of moving average. Alright, in Tableau, let's start by creating a new sheet and name it to moving average plot. Now let's create a monthly sales trend line chart first. To do that, I'll simply drag this order date field to the column shelf, that's our x-axis, and set it to show all months across the last 4 years available in the dataset. So to do that, I'll just right click on this order date pill, choose the month so it displays both the month name and the year, and then right click again to convert it to a discrete field. That way, every month's name shows up clearly along the x-axis. Now to plot the sales trend, just drag the sales field onto the row shelf. This instantly gives us a basic line chart. I leave the formatting details of this line chart to you, like adding labels, adjusting colors and tweaking styles, because I want to stay focused on explaining the concepts. Now to add the moving average line along this actual sales line, there are two ways to do it. If you have guessed them, great. So the one way is the simple quick table calculation method, and the other one is by simply using this manually created calculated field, which was basically a table calculation built with formula expressions. Alright, let's start with the first method, using quick table calculation. To demonstrate this, I'll first convert this sales pill in the row shelf into a moving average. So just right click on this sales pill, go to quick table calculation and pick up the moving average. And that's it. Now to see exactly how this moving average is calculated by Tableau, right click on this sales pill again and choose the edit table calculation. And the good news is that we already know this dialog box. It's where we tweak and customize the table calculations. So here, if I open this second drop down, we will notice it's using 3 values to compute the average, 2 previous values and 1 value at the 0th position, which means it's a 3 months moving average, right? And just like we did before in the table, check this option null if there are not enough values. With this checked, the first 2 data points in this plot, where a 3 months moving average cannot be computed due to insufficient data, won't appear in this chart. You can verify it by unchecking this option again and see first 2 values which are not the true representative of the 3 months moving average are displayed over here, and once I check this, we get rid of these first 2 values. That's pretty neat, right? And once you are done, just close this dialog box and you're good to go. Now that we have got the moving average plotted, let's add the actual sales line as well. So just drag the sales field onto the row shelf again and you will see 2 separate plots. This top one shows the 3 months moving average, while the bottom one shows the actual monthly sales. Now try to remember how we can merge these two into a single view, right? You can either use a combined axis or a dual axis plot here. Since the moving average and the actual sales aren't too far in scale, either approach like combined axis or dual axis chart will almost look the same, unlike our previous example where we compared sale versus discount where the scale varied a lot. But here, for the demonstration purpose, let's go with the dual axis chart at this time. But feel free to experiment with the combined axis option too. Okay, now to use dual axis plot and to merge these plots into one, so the left y-axis shows the moving average and the right y-axis shows the actual sales scale, just right click on the second pill in the row shelf and choose the dual axis. Now we have got a single chart showing both sales trend and the moving average trend. But notice by default, both lines have the same color, which is definitely confusing. So let's fix that. Just open this color legend and let's give the moving average line a distinct shade. I'll go with this green for better contrast. Now both lines stand out clearly. You can also customize this layout so that the plot fit its entire width. Okay, so the first thing to notice here is how different these two lines, the moving average and the actual sales line, differ from each other. This purple line is actual monthly sales and this green line is a 3 months moving average of sales. And as we have discussed already, a moving average smooths out certain spikes or drops. So if sales jump or fall sharply, the moving average stays more stable, right? To demonstrate this, take January 2020 as an example. In the December 2019, the actual sales was around 69k. Then the next month, in January 2020, they plunged to roughly around 18k. Therefore, this purple line shows a steep drop. But see this green line, which is a moving average of last 3 months, it showed a slight downfall and stayed nearly around 55k. Because this 55k is simply the average of the 3 months. This January 2020, which is 18k, plus December 2019, which is 69k, plus November 2019, which is 78k, and we divide this total by 3 to get this average value of around 55k, which is displayed over here. So that's the 3 months moving average in action. And this is a perfect illustration of how a moving average evens out the uncertainties in the actual sales trend line. Here's another quick quiz for you. Right now, our 3 months moving average smooths the actual sales line nicely. No problem in understanding it, right? But if we increase or decrease the number of periods or values in this moving average computation, how would that change the smoothness of this moving average green line? Think about using, say, a 2 months moving average or a 4 months moving average or even a 6 months moving average. How do you think each choice would affect the smoothness or responsiveness of this green trend line? So take a moment to think it through before we discuss the actual answer and demo it on the chart. Okay, I hope you must have figured it out already. Now if we decrease the number of months in this moving average, this green moving average line will start hugging the actual sales line more closely. So it gets less smooth and react faster to changes, right? But if we increase the number of periods, say 5 months or 6 months, the moving average line becomes much smoother, showing a more gradual trend, basically filtering out any short-term ups and downs even more. So to demonstrate it, let's try increasing the smoothness by changing or increasing the number of months to consider by editing this moving average calculation table over here. Notice, as we keep on increasing the number of months to consider in this moving average, the variability in the average sales value decreases. So that's basically what we call the smoothing. I hope this makes sense. Be sure to experiment with different settings yourself to find the optimal number of months to consider. Something that's not too jumpy and not overly smooth, so that it approximately captures this overall upward trend plus this slight sinusoidal behavior of the sales data. If I were to choose here, I'd go with the 6 months moving average. That's 5 previous months plus the 1 current month. So this green line becomes a 6 months moving average. That's capturing the overall trend plus this sinusoidal behavior in this actual sales data. So here we picked the 6 months moving average in Tableau visually. But in real projects, the data scientists determine this window size, for example this 6 months moving window, with techniques like cross-validation, which we'll cover later in the machine learning time series section. So for now, focus on understanding this intuition and simple mathematical interpretation and keep practicing all this table calculation implementation in Tableau. It will give you a strong base before we dive into Python and machine learning. Alright, so to wrap up and give you a complete view, I want to show you one final method of creating a same plot using a manual table calculation. That's the calculated field we built using this formula, remember? So let's quickly go through it. I'll first duplicate this sheet and rename it as moving average plot using formula. Then let's remove this quick table calculation version of sales field from the row shelf, and this leaves us with a basic line chart showing the monthly sales per month. For this demo here, we already saw that a 6 months moving average works well here. So the first step is to create a 6 months moving average calculated field. Now we don't need to start from scratch. We can simply duplicate this existing field that we created for a 3 months moving average and rename it to window average 6 months and edit the calculation. Once the dialog box appears, inside this editor, change the starting position from -2 to -5. This small adjustment makes the formula calculate the 6 months moving average, right? Once done, click OK. Now all we need to do is to drag this 6 months moving average onto the row shelf. And finally, we can simply merge the two plots into a dual axis plot. So in this 6 months moving average line plot, the next thing I would do is to hide the first 5 values from this orange line chart. And by now, you should know the reason very well. So just right click on this window average pill in the row shelf and choose the edit table calculation. And check the very first option that says null if there are not enough values. And just like that, you've created a dual axis plot showing both the actual monthly sales and the 6 months moving average. So with this, we have covered both methods here to build the same plot, using the quick table calculation and using the calculated field, which gives you a more flexibility to customize the calculation with the formulas. So in this video, we have covered a lot, understood important table calculation, their underlying mathematical concepts, and some really cool Tableau features. We started with the theory behind each type of calculation, discussed the business objective for the analysis, and implemented them in Tableau using all possible methods, from quick table calculations to creating formula-based calculated fields. I really enjoyed putting together this content to give you a well-rounded and exhaustive understanding of these fundamental data science concepts. I trust you will thoroughly practice what we have covered here. This will solidify your understanding and take your Tableau skills to the next level. Now in the next video, we'll dive into another key Tableau feature called level of detail or LOD expressions, which are one of the most important tools for advanced data transformation and aggregation in Tableau. So stay tuned and I'll see you in the next one.